Now let's see how we can find the trigonometric ratios of some specific angles. Because trigonometric ratio is identified with each of the ratio connected to the opposite side, adjacent side and hypotenuse of a right angled triangle. There are some specific angles for which we will try to find the trigonometric ratios. The specific angles here considered as 30, 45 and 60. So let's see how we can connect the trigonometric ratios for these three specific angles, initially to start with 45. So let me take first as theta equals 45 degrees, and let's see how the trigonometric ratios can be found for finding sine 45 degrees, cos 45 degrees and tan 45 degrees and the respective cosecant, secant and cot using the triangle properties. To start with this, if suppose the angle theta is 45 is taken for a right angle triangle where this is 45. So if one of the angle is 45, then immediately this being 90, 180 minus 90 plus 45 will also make this as 45. Therefore, this angle also will be 45. This makes us understand that this triangle is an isosceles triangle with this equal to this. Therefore, when I take the triangle ABC, AB is equal to AC because this is an isosceles right angle triangle. Angle B equal to angle C. So AB equal to AC. So using this property, let's see what we will get for the value of sine 45. To start with, let me just take each of the sides as A and A because they are equal. I take this measurement as A, so this will also be A. So let me see how I can find BC initially, because to find sine 45, which is opposite by hypotenuse, I need the hypotenuse first. So by using the Pythagoras theorem for the triangle, I have BC square equals AB square plus AC square. This is by the Pythagoras theorem. That implies my BC square, which is hypotenuse square, can be found using the right hand side of the Pythagoras theorem, where AB is already known to be A square plus AC, which is equally same for this isosceles right angle triangle, is again substituted for A square. That implies my BC is root of A square plus A square, which is twice A square. So this comes out to be A root 2. Therefore, my measurement BC is A root 2 out here. AB is A, AC is A, BC is A root 2 units. And using these three dimensions, it is very easy that I can find sine 45, which is sine theta, is opposite by adjacent, opposite by hypotenuse. Therefore, here the opposite side is A because I consider this angle 45. Then opposite to 45 is opposite side, which is A, and hypotenuse is obviously A root 2 is what I get. So cancelling A, which is non-zero because this is the length of the side, I get this to be 1 over root 2. Therefore, sine 45 degrees is 1 over root 2 is how we derive for sine. Now let's see how we can derive for cos. Cos 45, I get this as adjacent by hypotenuse with the formula as we have. Adjacent side, which is AB, that is A. This is the adjacent side, this is the opposite, and this is the hypotenuse. And hypotenuse is A root 2. Again, I cancel, I get 1 over root 2. Therefore, my cos 45 is 1 over root 2, which I get. That means sine 45 degrees is 1 over root 2 and cos 45 degrees is also 1 over root 2. The special angle 45 degrees taken out here gives this. Finally, we'll try to find tan 45 and see how we get the value. Let's see for tan. Now, as I see here, my tan 45 degrees for the triangle ABC is opposite side by adjacent. As we have the formula O by A, I can substitute to get opposite side, which is A, and adjacent side, which is also A, so that on cancellation it gives 1. Therefore, tan 45 degrees is said to be equal to 1, is how we understand tan 45. So now that we have obtained sine, cos and tan, we just try to understand that there is a relation between sine and cos. Let's see how the relation comes here. Clearly, if I consider sine 45 over cos 45, let's see what I would get. If I divide the ratio sine with cos, I get 1 over root 2 is sine 45, and cos 45 also is 1 over root 2, whereas this gets cancelled to give 1, which is equal to this. Therefore, this makes us understand that, therefore, tan 45 is said to be equal to sine 45 by cos 45 is what we get, in this case being equal to 1. So we got three trigonometric ratios, sine, cos and tan. Equally, we will try to find cosecant, secant and cot in the similar manner as we have done for sine, cos and tan. And sine, cos, tan connected as tan equals sine by cos. Now let's take the three trigonometric ratios which I have found, that is sine 45, which is 1 over root 2, cos 45, which is also 1 over root 2, and tan 45, which is 1. This leads each of them to find cosecant 45, which is reverse of 1 over root 2, that is root 2, and secant 45, which is reverse of 1 over root 2, that is root 2, and cot 45, which is reverse of 1, which is 1, is how we understand the reciprocal or the reverse trigonometric ratios and the three trigonometric ratios for the special angle theta equals 45 degrees. Secondly, we will try to see what exactly is sine 30 or cos 30 or tan 30, and then we find for special angle 60 degrees. Now the turn comes on identifying for 30 and 60 degrees.